Alright, it's time to get to learn about programming. If you don't know anything about programming, you've come to the right place. I'm going to go over programming in C# for Unity at a very basic level today. If you've seen the last part of the series, you will be familiar with the UI. If you haven't seen the last part of the series, you don't need it to understand here. We're going to specifically only be talking about programming parts. So let's remove this square real quick because we don't really need this. What we're going to do instead is I'm going to make a little UI element, and we're just going to add a legacy text for the time being. And don't worry about how the UI system works for Unity. We'll get into that more in detail later on. I'm just going to make this text a little bit bigger so that it's easier to see. And then we're also on this same canvas going to add a button, which will get a window up with a TMP importer. We imported TMP Essentials. TMP stands for Text Mesh Pro, which is the preferred method of using text in Unity. For now, we're not going to dive too deep into it. Again, that will be part of the video all about UI. We can make this button a little bit bigger, put it somewhere up on screen. But now what? Because we want to, when we press this button, change this text. But how do we do that? We're going to select the text, and we can see it's got a rectangle transform, which is a little bit different from the usual transform. But again, not too relevant. A canvas renderer, which just tells the engine, hey, this is a UI element. And then the actual text that we're seeing. So we can change this text to number 0, and we can see 0. But now how do we change this number through code? And the way we do that is we're going to add a new component. And we've already seen what we can do with components. We can add rigid bodies to them to make them fall through with gravity. But it would be really limited if you could only add components that Unity provides you with. So what we can do instead is we can just type in something like text updates, and we see, oh, it doesn't have any components for that, but it does give us the option to make a new script. So we can press on that. It automatically picks the name that we were looking for and makes that the name of the new script. So we can create and add, and now we have the text update script on this text object. I can also see down here in our project, we've finally gotten our first script made. So we can double click this and it will open your code editor, whatever it might be. Probably is going to be Visual Studio. And here we have our first bit of code. This is the template of all your scripts that are going to be made in Unity. Going to start by these 3 lines using System Collections Generic, and Unity Engine. Then is going to say public class and then the name of your class, the name of the script. And it derives from mono behavior. This just means that everything that the mono behavior script, which is all the functionality that Unity provides you, everything that's in mono behavior will also be accessible in text update. You can also do this for your own scripts eventually. So let's say you make a player script, but you have 3 different types of players. You can then make player 1, player 2, and player 3, which would be the individual classes, all derive from your main player class, which then derives from mono behavior. So that is to say that all those players won't need individual programming for everything that they need to share in functionality anyway, such as moving around and jumping and maybe like shooting. Next up, we have a comment. These things in green, they start with 2 slashes. These are not code. These are things that the engine is going to ignore while running the game, but will be useful for you as a programmer to be able to read, hey, this is what this is doing. Hey, this is where this functionality comes in. Then we have our first actual function. It's a void start function. This is a function that Unity provides you with, and a start just runs once when the game object is put into the world. The first frame that the game object exists, every bit of code you put into these 2 curly brackets is going to run. Void, what that means we'll get into a little bit later on in this video. And then here we've got update, and as it says, it's called once per frame. So if your game runs at 900 frames per second, the code in here is going to run 900 times in a single second. If you run at 30 frames per second, it's going to run 30 times. And I will also give you a little bit of extra here because that could be problematic, right? If you want to do certain things as far as like movement physics go, you don't want them to be dependent on the frame rate. So what you can do is you can make a new function that Unity already has made for, and that is the fixed update. So we can do private void fixed update. You don't actually need to specify private if you don't specify anything, works the exact same way. And fixed update will just always run 100 times a second. So if you need something to do with physics calculations and stuff that needs to be frame rate independent because you don't want your character to be able to run faster if you have a higher frame rate, right? You do it in fixed up. All these three things are what we call functions. And a function is nothing more or less than a list of instructions. So think, for instance, we want to move our character left every frame. Then in here we would just say move the character left, right? Of course, that's not how coding works, but then every time this update function is called, it will do whatever it says in here. And as we know, this update function is called every frame of the game. Now, aside from functions, which are a list of instructions, there's one other fundamental thing that you're going to need to understand about coding, and that is variables. There's a bunch of different types of variables. We're going to go over the most useful and most common one. In contrast to a function, which is a list of instructions, a variable is just a container for information. So we've got a bunch of different types of containers that then hold different kinds of information. So one of the most important types of information that you can have is a bool variable. And a bool variable is just a true or false. So a bool variable is a container for a piece of information that can either just say yes or no. There's no in between. There's nothing else in there. It can be yes or no, true or false, 0 or 1. Then we've got integers, which you're probably familiar with integers because those are just whole numbers. So let's call this integer number. So that's 1, 2, 3, 4, 5, 6, all the way up to like 44 billion something. And these can also be negative numbers. So we can have an integer that is negative 25 or positive 36 or whatever you want. An integer, however, cannot have a decimal place. So if you want 1.5 or 9 3/4, if you're a Harry Potter fan, that's not going to fit inside of an integer. For that, we're actually going to need a float, and those can have decimal places. So if you want 1.358796, for instance, which is a random string of numbers that have decimal place in it, you're going to need to use a float. For the most part, I would like to say don't worry about the difference between an integer and a float because it's a negligible difference as to what you use at what point, and integers are rather constraining. There's certainly reasons to use integers, which we'll get into in like a lot of different other tutorials where we actually use integers. But for the time being, just think if you need a number that's actually going to be used in some kind of math equation or some kind of functionality, it'll have to be a float. If you need a number count object, use an integer. That's kind of the main distinction between the two of them. And the last one that we're going to be talking about right now will be a string variable, and that is just text. So if you want to have your player name, for instance, that's going to be stored in a string variable. If you want to have the name of a weapon, that's going to be stored in a string variable. There's a lot of different things that we can store in a string variable because any type of text is a string. And with these 4 types of data that we can now put in these 4 types of containers called variables, you can pretty much make whatever you want if you're creative with them. There's a bunch of different other types of variables as well that we're not going to be worrying about for the time being. These are the 4 most important ones. So let's go over real quick what we've talked about so far. We've got our script file, which contains this class. In that class, we have variables and we have functions. The variables contain information, while the functions execute instructions. Unity comes with a lot of pre-built functions that you can just make and it'll know what it's supposed to do. You can make your own functions as well, which we'll get into a little bit later down the line. The start function runs once when an object is created. The update function runs every single frame of your game. So that can be a really variable amount of time. Could be 1,000 times in a second, could be 10 times in a second if you have a poor frame rate. The fixed update function is frame rate independent. This will just always run 100 times a second, no matter what happens. Now that we know that, let's start making a bit of functionality here where we have a variable that's displayed as the text that we just added to our UI. So let's delete these 4 variables that I've made, and we'll instead make a integer, and we'll just call that the number. In general, it's good form to start your variable names with a lowercase and your function names with a uppercase character. It's not technically needed, but as you go along and you're referencing other scripts all over the place, it's very nice and easy to be able to see, oh, that's a uppercase something, so that's going to be a function, or that's a lowercase something, so it's a variable. Anyway, we've got our integer, our number, and we've got our updates. But what are we going to do now? Because can we make a text? We actually can, but you can see something weird happens up here. And that is because these using lines aren't just for show. By default, your scripts won't be able to allow all the functions and all the variable types that exist. That's just an optimization thing. A object that has nothing to do with the UI doesn't need to know how to influence the UI. And if it doesn't know how to do that, it's going to make it more heavy to run, and you don't want that. So purely an optimization thing, but we do want to influence the UI because this is a text on the UI. So what we'll do is we'll say using Unity Engine.ui, and you end every single line in your code with this semicolon. You can see them up here as well, and I also put them after this number, as you might have been able to see. Semicolon just tells the code, okay, this is where one of my commands ends, so that it knows where the next one starts. A simple enter will not do that for a variety of reasons. So now that we've added the Unity Engine UI, as you go along with coding, you will start learning when to add these. And as you could see just now, since I'm using Visual Studio, it also knows that, oh, you're trying to add a text, but you can't yet because you need Unity Engine UI. So you'll learn this as you go along. Anyway, we can make a text with a capital T, and we'll just call that text with a lowercase t. And now we have a text variable as well that we can actually influence. So we'll go to the update function because we want to make sure that this always on every frame updates to reflect the value of the integer that we've just made. And we'll say text dot, and now we get all of the possible things that we can do with a text variable. So you can see there's a lot of different things here, and you can just look through this if you're interested, but really what we're looking for is just the text. So text.text, which is the string that it will display, is equal to, and now it requires us to put in a string. Let's put in our number and a semicolon because that's the end of the command, but there's an arrow line under that. Just because we as humans understand that a integer as a number can be written down doesn't mean that the computer understands. So we need to tell this that use this number and put it in a string because it's expecting a string, so we can't just give it an integer. Luckily, it's very easy to do that with most types of variables, if not all types of variables. You can simply add a dot and then toString with 2 parentheses at the end, and now it will take the value of this variable and put it in a string, and that will then be displayed as the value for our text. You'll note that the end of this needed 2 parentheses, and that's very much like the functions that we're seeing here, and that is entirely correct because toString is a function. It's a function that exists within the base of C#, really, within the integer variable itself. So surely that's it, right? Now this should work. So if we go back into the Unity editor, now we can just go into this. We have the text updates and this should work. Well, not quite, because number one, this text doesn't know which text it's talking about. There is a container here to have text information and be able to influence and change that, but it doesn't yet know specifically which text. There's a container, there's just nothing in it. We need something to point towards, hey, this is actually the data that we're going to be working with. And we can do that in a number of different ways. For the time being, since these are on the same game object, the best way to do that is to come up here in void start, which will run at the start of the game, and just say that our text is equal to get component text. This will look at the same object that this script is placed on and see, do I have a component of the type text? If so, then this variable will be set to that specific component on this specific game object. You could very well have 10 different game objects with all different types of text on it, so you need to show every single variable which version, which actual component on which actual object it's referring to. But we still can't increment this number at the moment because we've got this integer number which doesn't have a value yet. So by default, the value will be 0. We can't update that yet. So let's do that. We'll get rid of this fixed update because we're not actually going to use it. That's just there to show you. We're going to make our own function. It's going to be a void function and we'll call it increase number. And here we will put in the functionality that we want to happen to increase our number. So we can get our number and we can set it equal to being number plus 1. So it'll always take whatever value our number is and add 1 to it. So if our number is currently 20, when this function runs, it's going to become 21. If we've got 999 in our number and this function runs, it's going to become 1000. Now, there's two different ways of writing this specific command here, and I'm going to go over both of them. If it confuses you, don't worry about it. This is an entirely valid way of writing out increasing a number. We can even say increase it by 6 if we want, or increase it by 86, whatever. So, but if you just want to increase it by 1, instead of saying number equals number plus 1, what we can do actually is we can just say plus equals. This does the same thing. It will just add whatever is on the right side to whatever is on the left side. So this still allows me to add 15 if I wanted to, instead of just 1, or 23 if I wanted. But we want to add just 1. So another way to do that is to just put in your integer and put plus plus after it. There's a little shortcut, plus plus incrementer, which will just add 1 to whatever integer or float you're using it on. For now, and for ease of use, we're going to stick with number equals number plus 1. And I think now is a good time to dive a little step deeper into functions. Because why are these parentheses here? You might have been wondering this for the past however long this video is. And that is because you can put parameters or arguments in here. And you might be wondering, what is that supposed to mean? You can put variables in the function itself. So we put some variables up here at the top of the class, which means that everything in this script is going to be able to use these variables. But in this case, I want to make a parameter in my function, which is a variable that can only be used within this function. So the way we do that, within the parentheses, we put in an integer, just like we would do for any other variable. And we say number to add. Then instead of just adding 1, we can use that as a variable. And now we can call this function and we can say we can add 1 to it. Or maybe if we press a different button, we'll add 5 to it at once. Instead of having to make a different function for add 1 and add 5 and add 10 and add 50. And you'll note that if I want to use number to add in the update, so let's say that number is going to be equals to number to add, that doesn't work because number to add doesn't exist outside of this function. This function is the only place that number to add even exists. So let's get rid of this just because it was for showing you. Usually the way that we differentiate that is putting an underscore before the variable. That shows you it's local to that specific function. And now the final thing that we want to talk about for the time being is you might have seen the word private appear in front of this. And a function or a variable can be one of two different types of accessibility. That being private, meaning that only other things within this class, so everything within these two curly brackets up here and down there, will be able to use this function. But if we go to another game object and make it look at this script, everything that's private, it won't be able to see, it won't be able to use. So if we have a private function, the button object that's in our game will not be able to use this increment number. And it will need to be able to use it because pressing that button is going to increment the variable on this object. So instead of making it private, we can make it public. And a public function or a public variable can be seen by other scripts on other game objects. I'm also going to make this integer public just to show you that variables can be public too. And we could influence this from another script if you wanted. But more importantly, making a variable public will make it accessible to you in the editor. We still got this void thing going on here. For the time being, we're going to leave that alone. If you are interested in looking up for yourself what that does, void is the return type. You can make functions that return a value. So this could be a function that takes in a value and then puts back out for instance, an integer, right? Or a bool. This function, however, doesn't do any such thing. So if a function doesn't put a variable back out and just does some functionality, we call it a void because its output is void. It's nothing. It's zero. Again, not particularly relevant right now. So if you don't really understand what I mean by that, don't worry about it. We'll get to it at some point later when we get into a couple of steps further into beginner programming and maybe moving towards intermediate-ish programming. For now, just know that if you're making a function, it's going to need a return type. And for the time being, that's pretty much always going to be void. Finally, we are back in the Unity editor. And as you can see, we made the number a public variable. So now we've got a little field over here in which we can put in the number. Of course, the game isn't running at the moment, so the number in here doesn't change. But if we run the game, we can see the number here is 50. And if we change it to 60, it changes to 60. And now to 80, and so on and so forth. So let's put it back to 0, because what we want to do is we want to have this button over here. When we click it, increase this number. A button comes with a on-click event. So we can add something to this list and it will ask for a game object. So it'll be looking for a specific object that is going to pull functionality from. For us, that's going to be this text object that has our text updating script. So we can pull that into this field over here. And then this drop-down menu becomes available. At the moment, it's doing no function. So we can click on that and we can go to our text update script, the one we made, and we'll see a bunch of different functions that Unity just automatically puts on this kind of game object. But most importantly, we can see the increase number function that we've made ourselves, and it shows you it takes in a integer. So we select that one and then we say we want to update this by 1. Now if we run the game and we press this button, we can see it updates our number by 1. But if we say, actually, I think this button should probably update this this number by 5, we can just change this value in the on-click event, and now it's adding 5 to it every single time we see it. And of course, the next logical step there is having this button increase the value by 1, and then having the button selected and pressing Ctrl D will allow you to duplicate it into a new separate game object. So we can just drag that down. We've got 2 buttons now. And on this button, we can say this one is going to increase it by 5. So now we've got a button that increases by 1, and we've got a button that increases by 5. So we've got this button increases by 1 every single time we click it, and this button increases by 5 every single time we click it. I know that was a lot of information. It's very information dense, and if you're very new to coding, it's going to take a little bit to wrap your head around all of this new information. I wanted to keep this as entry level as possible because it's difficult enough to get into as it is. As we go along and as you figure out other type of things that you want to make, and if you figure out, oh, I should be watching this tutorial for this function or whatever, you will start to build up your knowledge. It's very much a matter of once you understand these basic ideas that I've explained to you here today, from here on out, it's building your knowledge of what tools you have accessible, what types of variables exist, what type of built-in functions exist. So I do implore you to, after you've watched this, to go ahead and before you keep on going with the rest of this, just open Unity and give yourself an hour or two to play around with making something like you see here. And if you want to take a challenge, come up with a simple idea and try to make that as well. Maybe make something that will change the position of your player. Like just a simple square. Just make something that changes the position of a square when you press a button. It's a little bit of homework, but it's important for you to put this knowledge and understanding into practice so that it can really solidify. Next time, we're going to start on making a little bit of actual gameplay. And thanks to my patrons, you can see them on screen right now. And a special thank you to my Cave Digger tier Patreon, Syntax.